Next, we'll work problem 12.2, hydrogen bonding. Which of these compounds is a liquid at room temperature and why? First, we have formaldehyde. Second, we have fluoromethane. And third, we have hydrogen peroxide. So they all have a similar molar mass of around 30 grams per mole. Notice that formaldehyde has a polar bond, and so formaldehyde is actually it is planar, but we have a vector going in this direction. But notice that formaldehyde does not have an oxygen with a hydrogen attached. Fluoromethane has a polar bond. We have this fluorine bond, and it is polar, but we don't have a hydrogen on the fluorine itself. But hydrogen peroxide has two oxygen-hydrogen bonds. So this molecule exhibits hydrogen bonding, which makes hydrogen peroxide a liquid at room temperature. The next question is, which has the higher boiling point, HF or HCl, and why? So I've made a note here. This is kind of a difficult question according to the information that we've been given. If we look at the periodic table, here is fluorine and here is chlorine. So we were told that HF has hydrogen bonding because the electronegativity difference between hydrogen and fluorine is greater than hydrogen and chlorine. Okay, and that makes it a stronger effect. Okay, the boiling point for HF is 19.5 degrees C and HCl is negative 85 degrees C. So we can see that HF has the higher boiling point, and that's due to that larger electronegativity difference. But we did learn earlier that the larger atom is going to have the higher boiling point. So I wanted to point out that this is really an opposing trend, and I wouldn't really want to give you a question like this on purpose. But the electronegativity difference here overwhelms this atom size difference, and therefore HF has a higher boiling point.